objectives for today's lesson: illustrate distinguishable permutations and permutation with repetitions, solve problems involving distinguishable permutations and permutation with repetitions. So let's get started. How are we going to arrange the letters from the word DAD? So from our previous lesson, we know that we have the following arrangements. So permutation of 3 taken at 3 is equal to 3 factorial. And if we're going to list down all the possible ways of arrangement, we have 6 possible arrangements. But what if we are going to write DAD in this way? Capital D, capital A, and capital D. So notice that we have DAD, a similar one, ADD, a similar number 2, and DDA, a similar number 3. So it means that we have 3 distinct ways in arranging the word DAD. Distinguishable permutations or distinct permutations refers to 2 different arrangements of objects where some of them are identical. So for this example, we just count the number of things which are alike. So for this case, we have 2 B's. So to find the number of arrangement, we just divide the total number of things that we are arranging or we are choosing from, which is 3, divided by 2, which is the number of repetitions that we found on this word. So we have permutation of 3 taken at 3 over permutation of 2 taken at 2 equals 3 factorial over 2 factorial, or 6 divided by 2, which is 3. The number of distinguishable permutations of n objects of which R are alike and S are alike and so on can be found using this formula. Permutation equals n factorial over R factorial times S factorial and so on. So n stands for the number of objects, R stands for the objects of one kind, S stands for the objects of the second kind. Let us have the first example. Find the number of permutations of the letters of the word statistics. So for the solution, notice that we have 3 S's, 3 T's, and 2 I's. So the formula to be used is permutation equals n factorial all over R factorial times S factorial. So substituting, since we have 10 letters for the statistics, we have 10 factorial, and that would be the numerator, all over the repetitions of 3 S's, 3 T's, and 2 I's. So we have 3 factorial times 3 factorial times 2 factorial. We evaluate 10 factorial, which is 3,628,800, all over 6 times 6 times 2. So the result is 50,400 permutations. For example, number 2, there are 3 identical green flags, 3 identical white flags, and 2 identical red flags. Using all 8 flags, how many signals can be given? So for the solution, we have 3 green, 3 white, and 2 red flags. Using the formula for the distinct permutation, we have P equals n factorial over R factorial times S factorial. So substituting the value of n, which is 8, in the formula, we have 8 factorial over 3 factorial times 3 factorial times 2 factorial. Evaluating 8 factorial, which is 40,320, we divide it by 6 times 6 times 2. So we have 560 distinct permutations. For example, number 3, how many 6-digit numbers can be made using the digits 422955 or 422,955? So for the solution, notice that we have 2 2's and 2 5's. So using the formula, substitute the value of n, which is 6 factorial, all over 2 factorial times 2 factorial. We evaluate 6 factorial, which is 720, divided by 2 times 2, which is 4. So we have 180 distinct permutations. Let us deal with this problem. Using the letters SET, how many three-letter words can be formed if repetition of letter is allowed? Notice that for this problem, three locations are needed. So there are three letters which can be used to fill the first location. So we place 3. Because repetition of letter is allowed, so it means that the same 3 letters can be used to fill the second location and also the last location. So multiplying them, we have 27 possible arrangements. There's an easy way to calculate when you have n things to choose from and you have n choices each time. So it means that we just have to multiply n times and so on. R determines the number of times, or we use the formula n raised to r. N stands for the number of objects or the number of things we are choosing from, while R stands for the number of spots or locations we have to put on those items. Let us deal with example number 1. How many 3-digit numbers can be formed with the digits 1, 2, 3, 4, 5 if repetition is permitted? So for the solution, we have n, which is equal to 5, or the number of things we are choosing from, and r stands for the number of spots we have to put on those items. So we will be using the formula P equals n raised to r, substituting n, which is 5, and r, which is 3. So it means that we have 125 permutations. For example number 2, consider the set of letters PLACES. How many 4-letter words can be formed if repetition of letter is allowed? So for the solution, n is equal to 6. Since we have 6 items or number of things we are choosing from, and r, which is 4, since we are forming 4-letter word. So P equals n raised to r, substituting the value of n, which is 6, and r, which is 4. So we have 1,296 permutations. Try doing this on your own. Until our next session, thank you and enjoy learning.